In our last video, we took a look at how we're going to go through and find the probability given a raw score. But what if for some reason we want to go backwards and we're given the probability, but we want to find the raw score? And a lot of times this is done in standardized testing, or if we're trying to classify a population, maybe we want to figure out not the quartiles, but specific percentiles. And maybe we don't necessarily know what the observations look like, but we do know that the population is normally distributed. And so if this is true, what we can do is we can use the normal distribution in our formulas to kind of go backwards. So it's almost like an inverse function for those of you guys that might remember that from either college algebra or pre-calculus if you ever studied that. Now, remember we have our formula that z is equal to x minus mu divided by sigma. Right? And in the previous problem, we knew that the mean was 72 and we knew the standard deviation was 7. And what we're going to do is we're just going to use that information to be able to find the grade that begins the bottom 15th percentile. Right? So let's go ahead and graph the distribution. Right? So this is our normal distribution. And we're looking for the bottom 15th percentile. So we know that 15% on the bottom or the left side of the curve looks something like this. And right here, this is 15%. Or in other words, that's 0.1500 if I was to convert that into a decimal, accurate to 4 decimal places. All right, so that's what we're working on. Now, usually what we do is we go through and we try to solve this for z, and then we convert it into an area. But we do have the area, or the probability. What we're really looking for this time is we're looking for the x value, which means that what we need to do is we need to be able to get z. Right? So what we're going to do is we're going to go into the table and we're going to look up as close as we can to be able to get 0.1500, not as a z-score, but we're going to convert that into a z-score. So now, one of the first things that we should remember is which side of the table do we need to be on? Is it the negative or the positive side? We know right here is 72. This is our value of x that we're looking for. And so since we're on the left side of 72, we're going to look at the negative side of the table. So the z-score should be negative because we are so many standard deviations below the mean. So let's take a look and let's see if we can find 0.1500 in our table. So we're on the negative side, right? So we need to make sure that all the z's are negative. And usually what we do is we look up 0.15 and we try to go into the z-score. But we don't care about the z-score yet, we care about the area. So we're going to look in the table, and right here is what we're trying to find. Okay, so we just have to do like some searching, and we have to try to figure out, that's 0.015, excuse me, that's not correct. We're looking for 0.15. So that's going to be a little bit further down, so excuse me. So if we look for 0.15, I don't know if we can exactly get 0.15, but we can get to one of these two numbers. All right, so these are the two values that are closest to 0.15. Technically, this one's a little bit closer. All right, because notice this is 0.1515, so you're 0.15 away. This is 0.1492 approximately, so you're 0.08 away. So technically, you'd probably want to use this one, all right, but it's okay if you use the other one, all right? So what we're trying to do is we're trying to use one of the z-scores that's really close to 0.15, all right, and we're going to trace that over. And usually what we do is we just say that's the probability, but now what we're doing is we're going backwards and we're looking for the z-score. So the z-score is going to be negative 1.04. So our z-score is going to be negative 1.04. All right, so again, look into the chart, and you're just looking up as close as you can to 0.1500, bottom 15th percentile, and then you're lining it up. You're going the other way of crosshairs. All right, so it's like an inverse. You're doing the reverse. Well, now that we know what the z is, now we can substitute it into our formula. Okay, so remember we have our z equals x minus mu divided by sigma. We know now that z is negative 1.04. We don't know what x is. If we did, we wouldn't have this problem. And We know that mu is 72, and we know that sigma is 7. Right? And now we just have a linear equation to solve. So to solve this equation, what we're going to do is we're going to multiply both sides by 7. So 7 times negative 1.04 equals x minus 72 divided by 7 times 7. So the 7's cancel out. 7 times negative 1.04 is negative 7.28 equals x minus 72. And if you don't trust me, you can go ahead and multiply it in your calculator. And then the last thing you would do to isolate the x is you're going to add 72 to both sides. Right? So it's just like a linear equation. So those cancel out. And we take 72 minus 7.28. I believe this is going to be 64, not 6.4, 64. I don't know where that decimal point came from. So 6.472 is equal to x. But I'm going to check that in the calculator just to make sure. So we're going to say 72 minus 7.28, and we get 64.72. All right. So that's the value that begins the bottom 15th percentile. And one of the last questions we should ask is, does that make sense? So let's go back up. And right here would be 64.72. And that kind of makes sense because 64 is less than 72. But it's not so far away that it will be completely unbelievable, like, 5 or 10 or 15 or something like that. So just think to yourself, does it make sense? All right. One last thing is that we are one standard deviation below the mean. Okay, so remember what a z-score represents. Okay, so this means that we are about one standard deviation below the mean. And if we took 72 minus 7, because that would be mu minus sigma, that would be 72 minus 7, which would be 65. And 65 would be really, really close to 64.72, which it is. All right, so just some ways for you all to be thinking about, does the answer make sense? All right, so a lot of times we get our answers, but we want to make sure that they're logical. All right, now, a secondary example. We want to figure out the grade that begins the top 5th percentile. All right, so let's kind of get an idea of what that looks like. So top 5th percentile is going to be on the right side of the graph. So here's our graph. And here's our top 5th percentile. All right, so here's x, and we have our mean, which is 72. We have our formula, z equals x minus mu divided by sigma. We know that mu is 72. We know sigma is 7. And this area is 5% because it's the top 5%. And usually what we do is we say, okay, well, I'm going to convert that to area and then take the complement of that. All right. So remember, one of the things that we always did with a right sort of area, if it was a more than problem, was we subtracted from 1. So to get the top 5th percent, that's really the same thing as the bottom 95%. Right? And our table, our z table, is only geared to be able to give us the bottom 95%. So right here, what we're going to do is we're going to say that we're going to just convert this, and we're going to say this is really the 95th percentile at the bottom, or 0.9500. Right? Now what we're going to do is we're going to take 0.95, not 9.5, 0.9500. And we're going to convert that into a z-score, just like we did before. Now, because we're on the right side of the graph, we're going to look on the positive chart. Okay, so let's go to our chart. Let's see if we can find 0.19500, or as close as we can. All right, so right here is like our 0.98, etc. So it's a little bit further down. So there's two values that are pretty close. Okay, so these two values are really, really close to 0.9500. And it really doesn't matter which of the two that you use. Technically, this one is just a little bit closer, like a couple, maybe 100 thousandths or something like that. So in reality, it's not that big of a deal. Most statisticians would use 1.645, but what we're going to do is we're going to use 1.6, and then we're going to trace it up, and we're going to say 1.64 just for our purposes. So you can either use 1.64 or 1.65. It really doesn't matter too much which one you use. All right, the error or the difference is going to be so minute that, especially for our class, we're not going to care. All right, so this is going to convert into 1.64. And then what we're going to do is we're going to substitute that into our formula. And remember, we're solving for x. And so our formula, z equals x minus mu divided by sigma, now becomes 1.64, which is the z that we just found, is going to be equal to x minus 72, which is the mean, divided by sigma, and we already know sigma is 7. And just like we did before, what we're going to do is we're going to multiply both sides by 7. So 7 times 1.64 is equal to x minus 72 divided by 7. The 7's cancel out on the right-hand side of our equation, and that just leaves us with x minus 72. And then 7 times 1.64, I think that's going to give us maybe 11 point something, so it's really close. So 7 times 1.64, 11.48. So that's going to be 11.48. And then just like we did before, to eliminate that negative 72, we are going to add 72. And finally, our answer, 8348. And we're going to plot it just to make sure it makes some sense. So we go back up here, and our x is going to be 8438, or 8348, excuse me. Right? And that makes sense. Okay, that's about 11 over 11 and a half. So it makes sense, and it's more than one deviation, but less than 2 deviations. So, so 1 deviation would be 79 by adding these two. 2 deviations by adding 14 would be 76. All right, so, or 86, excuse me. So we have 79 and 86. So our answer should be between 79 and 86, which it is. All right, and again, to be able to approximate that, what I did was I found mu plus sigma, which is 79 or 72 plus 7, which is 79, and mu plus 2 sigma, which is 72 plus 14, which is 86. And our answer should be between there because we're 1.64 deviations above the mean. And so it does make sense for our answer. Right? So again, just making sure that we understand what these things or what these solutions represent. Okay, so hopefully this gives you an overview as to how to work with the normal distribution, how to be able to find probabilities, how to graph a normal distribution, and then finally, how to be able to go backwards and find percentiles with respect to the normal distribution.